I gave something of an introduction to the concept of trig identities at the end of yesterday's videos, and I guess I wanted to give a different introduction. There's lots of different ways to introduce these, and I want us to look at it a different way. This is going to be a real quick video, I think. I want you to think about the graphs of y equals the cosine of x minus pi over 2, and the graph of y equals sine x. So sort of like mentally graph both of those graphs. So like pause the video and do that. So when I do that, I sort of think to myself, well, I already know what sine x looks like. Sine x effectively starts here, and it's going to complete itself at 2 pi over here. Like we know sine basically looks like this. So what about cosine? I know that cosine usually starts up here and sort of, does this kind of a thing. But this time I'm supposed to take this graph and I'm supposed to shift it, and if you think about this, I'm supposed to shift to the right by pi over 2. So instead of the graph starting out here and going up, it's actually going to start here and go up and go down and end like this. At which point we realize, like, whoa, oh my goodness, like this is crazy. Apparently, the cosine of x minus pi over 2 is equal to sine x. The idea is we can see that those graphs are equal to one another, and because of that, we have to conclude that these two statements are literally equal to one another. This is what's known as a trig identity, because it means that you can completely replace one of the expressions with another. It means that both of these equations, these expressions, are equal to one another for any value of x that you use. And we've got a laundry list of those things. We've got like 4 more videos lined up for this lesson today because I've got so many identities to talk to you about. And I'm going to try and keep each of them short. But actually, I want to challenge you to see if you can verify this identity in some other way. So, I mean, if you want, pause the video for a minute and see if you can think of a way to verify that that's true. Like, we effectively just verified or showed that it was true by graphing both of them and noticing that the graphs are the same. But there's another fairly reasonably easy way to verify this identity. So pause the video and think about that. If you can't think of anything after a couple minutes, I'll give you a hint. So the hint is, surprise, surprise, think about the unit circle. Pick an angle x, and then think about what does x minus pi over 2 mean, and see what your brain does with that. So this is what I'm thinking. Imagine you've got the unit circle. Pick any angle x, right? And imagine what is the sine of that angle. Well, as always, we think about this sort of triangle sort of thing, and we imagine that the sine of x is the vertical component of that. But now, what is x minus pi over 2? X minus pi over 2 basically means sort of 90 degrees off from that. It means this angle here. So for that thing, we would think about this triangle. But the idea is, due to symmetry, these two triangles are effectively the same triangle. And this long side here, the sine of x, becomes this long side here, which is the cosine of this different angle, and that different angle is very specifically the cosine, x minus pi over 2. So the idea is we can verify that identity also by thinking about the unit circle, by thinking about these and thinking about the symmetry of all of these things. And I really hope you guys get a good sense for the magic of this stuff, because it's just amazing to see the sorts of things you can do. So I hope you're excited. I'll see you in the next video.